Everybody's talking about Groq. You're on cloud nine, it
Groq,
seems.
Groq, 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 Groq.
So Groq is the most popular topic for the past 2 weeks in AI. It seems that they introduced a new concept called LPU, which is a new type of chip that designed specifically for AI and large language model inference. It demonstrates some off-chart performance for large model inference speed. And there are a lot of discussion about Groq. But to me, it wasn't very clear about what this LPU is. How is that different from all the other different PUs we already have before? And more importantly, for someone who is building AI products, what does it actually mean to us? How can we actually build with Groq API and unlock some really interesting use case? So for the past 2 weeks, I did a lot of research, talked to a few engineers from Groq, and also hands-on developing some real-time large language model application with the speed of Groq. So I want to share those learnings and show you a step-by-step demo of how can you build a real-time AI sales that can call potential customer, follow up with them on WhatsApp to close deals.
So what specific fitness goals are you looking to achieve?
I just want to lose some weight. I haven't done exercise at all for the past 3 or 6 months since COVID.
I totally get that. Our personalized training and nutrition programs can help you reach your weight loss goals. Let's discuss the membership options that are best for you.
Okay, sounds good. I think I'm pretty happy to just go ahead and get the membership started this Saturday, if possible.
Great to hear that. To complete the process, I just need your credit card number to secure your membership.
But before we dive into Groq LPU, it's probably useful to have a quick one-on-one about all the other PUs that we already have. So first, the CPU, which represents for central processing units. You can almost consider it as a brain of your computer. It runs the operation system, interact with different programs, and also responsible for connecting different hardwares together. So basically, every time when you interact with a program, copy or deleting files, all those things are done by CPU. One weird fact about CPU is that it is actually not great at multitasking. At any given time, our computer is almost always running multiple different programs. But the truth is, each CPU core can only handle one task at a time. Modern CPU do normally have more than one core to achieve certain level of parallel tasks. But even for the most powerful CPU, like Intel i9, it only had 24 cores. But the reason why we feel like the computer is running hundreds of tasks at the same time is because CPU is incredibly fast. So even though it is executing tasks in a linear sequential process, because it is so fast, we didn't even realize it is doing a linear process. However, when it comes to tasks that require massive parallel computing, CPU is not enough. If you're playing game at 60 Hz per second, with 1920 multiplied by 1080 resolution. In every frame, there are more than 2 million pixels need to be calculated and computed. So even though CPU is fast, it's not enough. And that is where GPU come in. And Miss Buster actually did a quite amazing demo to demonstrate the difference between CPU and GPU.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
9,
8,
7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over.
Just as what do you see in this demonstration, GPU has a fundamentally different architecture compared with CPU. The state-of-the-art CPU like Intel i9 has 24 cores. Can you actually guess how many cores a GPU like NVIDIA 4080 would have? It actually has almost 10,000 cores, which means it can do hundreds of times more tasks at the same time compared with CPU. So even though each core on GPU is not as powerful as what you have on CPU, but altogether it delivers amazing performance for tasks that can actually break down into subtasks that can be run in parallel. And for a very long time, GPU has only one purpose, which is for gaming and graphic rendering. But what really changed the GPU market is when NVIDIA introduced CUDA in 2006. Basically, they realized that there are a huge amount of use cases apart from gaming and graphic rendering can also utilize those parallel computing power. For example, training deep learning AI model require massive compute on huge amount of data, as well as crypto mining, which also require huge amount of computation that can be parallel. All those use cases drive huge demand for GPU company like NVIDIA or AMD. So the question now is, if GPU is already so powerful, why do we still need LPU? Well, the problem with GPU for large language model inference is that its multi-core complex architecture leads to some unpredictable results and latency, specific for large language model inference. For example, as we mentioned, GPU is designed for a scenario where parallel tasks make sense, which means the task can actually be broken down into individual subtasks that can be completed without dependencies, which is like gaming. There's no real sequential order or connection between the computation of each pixel. But when we move to use cases like large language model inference, the nature of those large language model or transformer works is that it is sequential, because each new word prediction is purely based on the previous words came out. So the order of execution actually matters here. And that means each computing unit has to know what other tokens has been generated before. But since GPU is designed for parallel task scenario, to achieve those kind of sequential order execution, it requires quite complex controls to making sure each GPU core, which is like a little box here, can read and write data to multiple levels of cache as well as memory. For example, when each GPU core is trying to complete a task, if they found all the data they need in level 1 cache, which exists on their own unit, then it can complete the task. But if the data they need doesn't really live on the level 1 cache they have access to, then it will need to wait. And this can happen many times for different GPU units. This leads to latency and also idle computing resource while it is waiting. And to optimize that, traditionally, people will write a huge amount of CUDA kernel code to optimize this performance and control where the data will. And writing those CUDA code is actually not fun. It requires a lot of work. Fireship actually just made an amazing video about CUDA to showcase how can you write CUDA code. And they'll probably give you a taste about what does that feel like to write CUDA code.
CUDA includes device drivers, a runtime, compilers, and dev tools, but the actual code is most often written in C++, as I'm doing here in Visual Studio. First, we use the global specifier to define a function or CUDA kernel that runs on the actual GPU. This function adds two vectors or arrays together. It takes pointer arguments A and B, which are the two vectors to be added together, and pointer C for the result. C equals A plus B, but because hypothetically we're doing billions of operations in parallel, we need to calculate the global index of the thread in the block that we're working on. From there, we can use managed, which tells CUDA this data can be accessed from both the host CPU and the device GPU, without the need to manually copy data between them. And now we can write a main function for the CPU that runs the CUDA kernel. We use a for loop to initialize our arrays with data. Then from there, we pass this data to the add function to run it on the GPU. But you might be wondering what these weird triple brackets are. They allow us to configure the CUDA kernel launch to control how many blocks and how many threads per block are used to run this code in parallel. And that's crucial for optimizing multidimensional data structures like tensors used in deep learning. From there, CUDA device synchronize will pause the execution of this code and wait for it to complete on the GPU. When it finishes and copies the data back to the host machine, we can then use the result and print it to the standard output. Now, let's execute this code with a CUDA compiler by clicking the play button. Congratulations, you just ran 256 threads in parallel on your GPU.
So as you can see, writing CUDA code requires a lot of low-level computing to control how the data flow. It's pretty complicated, and team can spend months to optimize those code. So as a quick summary, the problem with GPU during the large language model inference stage is that it has latency and unpredictable results, and also time-consuming optimization while writing those kernel code. But how is Groq LPU different? Well, if GPU is a general purpose chip that's designed for many different scenarios, LPU is type of chip that's designed specifically for large language model inference scenario. Unlike GPU, which has thousands of different cores, LPU have a much simpler architecture. It only has one single core. It also has direct shared memory across all the processing units, which means at any given time, all processing units will know exactly what other token has been generated before. And this predictability leads to a lot of performance gain. And I saw this one analogy from one of the Groq interview is quite interesting. With high predictability of where the data flow inside the chip, it means much higher utilization of the resource and also much more predictable performance for developers. So this simplified architecture that designed specifically for sequential tasks like large language model inference is what made Groq so fast. So in summary, GPU is like a general purpose processing unit for parallel tasks. It is actually still probably the best option for training the AI models, because during the training process, you actually want a lot of parallel task execution. But LPU is a chip that designed specifically for inference and sequential tasks to achieve low latencies. But one thing to note is that Groq is not a type of consumer-facing solution. Each LPU has around 230 megabyte memory. And that means to run a model like Llama 70B model, it will require almost 572 cards. So Groq is really have two services. One will be targeted at enterprise who do have capital for such massive setup. The other side, for normal developers, Groq will be the cloud platform that run the chips themselves and rent out this computing power. But for people who are building AI products, the most important question is what kind of use case is actually unlocked by such fast inference speed? There are a few use cases I personally very interested in. The first one is voice AI. A lot of people have been trying to build AI that can listen to the conversation, respond back just like a real human. But the problem so far has been the latency. Because for those real-time conversations, even 1 to 2 seconds delay can make the conversation feel less fluent. But for the past few months, with the development of speech-to-text model like Whisper, and now with super fast real-time inference as Groq deliver, these two things together, we can finally deliver a real-time conversation bot. And in a Groq interview on CNN, they also demonstrate a similar real-time voice AI demo, which is really impressive.
Hey, I'm Groq. You can talk to me like I'm a person.
All right,
How
I
can
will
help you
do.
today.
What makes you different from a large language model that I may have used in the past?
Sure, I'm a bit different from those big language models you've used before. I'm a language user interface, or LUI, designed to have more natural
Got
engage
it.
in
How
conversation.
similar are you to a human brain?
Well, I'm not a human brain, but I'm designed to understand and respond to you like one.
Yeah.
I can process and generate human language in a natural way.
Got it.
But I
Tell
don't
me
think
something most people don't know.
Here's something interesting. Did you know that octopuses have 3 hearts? 2 pump blood to the gills, while the third pumps it to the rest of the body. And when an octopus swims,
you
the
tell
heart that
him?
delivers
No,
blood to the
are
body
you
stops
sure?
beating, which is why
Are you
octopuses
kidding me?
prefer to crawl rather than swim.
As you can see from the demo, when the latency really reduced, the user experience feels really different. So I definitely think now is a great time to start building use case with voice AI. But on the other hand, I think a lot of people didn't realize Groq is not just for large language model, but also really good for other sequential tasks like image or video processing. This is another demo that Groq has showcased, where they deliver almost real-time image processing.
So basically, the way that this works, we're just going to select a photo here. I've got some headshot that I found online. And what I'm going to do is upload this to our system. Now, what this is doing is it's sending that file from my desktop over to the LPU inference engine in our data center. And now you can see there are these 8 tiles that show up at the bottom. Now, in the 8 of these tiles, you'll see each one is named with a label like surprised, angry, afro, curly hair, etc. And each of these is actually a GAN model that is trained on that particular image style. Now, I haven't applied any of these and we haven't run the model yet. And when I click merge, it's actually going to apply that model to this source image. Now watch when I press click. 3, 2, 1, click. You can see how fast that actually loaded across all of these 8 models. And that happened in parallel on a single node that we have over in our data center.
I saw this demo is extremely impressive. That just got me thinking, what if we have all this image or video processing in real time? That would just unlock so many interesting consumer-facing use cases. And I'm sure there are more use cases that you guys are thinking about. So definitely comment below for the interesting thing that you think we should look into. But the part I want to demonstrate how you can build is a voice AI. And specifically, I'm quite interested in the outbound sales agent use case. Because with a real-time voice AI, you can really build such an outbound sales agent who can cold call customers. And when I think about it, it's actually pretty straightforward in terms of the flow. You basically have a speech-to-text model like DeepGram or Whisper to do the transcription, and then send to Groq to generate a response. Then use text-to-speech model like PlayHD or 11 to stream in the audio. You can totally build this by yourself from scratch, and I actually tried it. But the challenge I found is that even though the model itself is extremely fast, there's still a lot of optimization need to be done to make the experience feel good. For example, I need AI to actually really understand conversation and kind of mimic when they should pause and when they should interrupt, just like a real human do. And also when do we stream in the data to a different model to actually get a real-time response, because it actually involves multiple different models. But I did find a platform called vapi.ai, where they provide a platform for AI developers to build integrated voice AI into their platforms. And they're handling a lot of heavy work in terms of optimization, speed, and latency. And the most important thing is that they actually support Groq as a model. So I'm going to give you a quick demo of how can you build a real-time voice AI assistant into your platform. So basically, you can create a voice AI assistant by calling their API, connect to a phone number that you purchased from like Twilio. Then you can just call their API endpoint to make a phone call to a specific customer with the assistant you created. And they provide a front-end playground so you can quickly experiment with different settings. So after you log in, you will have a page like this. You can create a new assistant. You can define different provider. So as you can see here, I choose Groq as a provider here since it is fastest. And then I can define, okay, what's the first message AI should say after a user pick up a phone, and also define a system prompt. They can also define the voice. There are a list of different providers, but PlayHD seems to be the one that has the lowest latency. And then you can define the transcriber and even function calling as well. So you can get the AI agent to do certain tasks like log information to a CRM or register membership, things like that. Unfortunately, if you're using Groq mixture model, it actually didn't support function calling yet. So to use this, you have to use GPT 3.5 model. So we're gonna skip this part for now. And in the end, you can also define server URL. So this basically means you can set up a webhook to receive the call transcript after call finish. And this is quite useful because you can send the transcript to another agent and it can decide what actions it should take based on the things that has been talked about. And once you set up everything, we can quickly try out by clicking on this Talk with New Assistant button.
Hey, I'm Emma from Crazy Fitness Gym. How's your day?
Hey, Emma. My day is pretty good. Thanks for asking.
Glad to hear that. Are you currently a member at a gym or are you looking for a new one?
I'm not in any gym membership at the moment, but I'm thinking about getting one because I kind of gained a bit of weight for the past few months.
I see. It sounds like you're looking for a gym that fits your schedule. Crazy Fitness offers flexible hours. Would you be interested in knowing more?
Yeah, sure thing.
Great. We have various membership options. Do you have a specific goal or area you'd like to focus on?
Yeah, I want to like lose some, do some weights so I can handle a bit more, kind of build up some muscles, if that's helpful.
Got it. Our gym has personal trainers who can tailor a workout plan for weight loss and muscle building. Sound good?
Yeah, sounds good. Happy to give it a try.
Awesome. To get started, I'll need your credit card details to set up your membership. Can you please provide the card number and expiry date?
So this is a quick demo of this voice AI with like 5-minute setup. And you can really play with different system prompt and there are a list of different settings you can play with to optimize the experience. But before we do that, the next thing we want to do is set up a phone number for the AI assistant so it can make calls. If you're based in US, you can just buy a phone number on their website directly. But if you're not in US, like me, you can just go to Twilio to buy a phone number and then import here. If you never used Twilio before, you can create an account. And after you're done, you can click on this buy additional phone number button. This will take you to this buy phone number page where you can search for any country in the world and select the voice ability. Then just choose a number that you want to buy. And after you finish, you can go back to the home page. There's account info card where you can copy the SID, auth token, and phone number. And after you're done, you can click on this phone number tab at vapi.ai and click import button to import it and put in the Twilio phone number you just purchased by adding the SID, auth token, and give a label. And that's pretty much it. And once you finish, you can just get an agent to make a phone call by making a simple API endpoint call. So it is very easy to integrate into your own system. They also allow you to create a new AI assistant on the fly. And this makes the use case a lot more flexible, because now you can insert different variables like customer's name or even the purpose of call and past conversation you had with this customer in your CRM. There's a bunch of data you can insert into the first message or system prompt. And I can quickly show you how you can integrate this voice AI into your existing agent capability. For example, I already created a gym sales agent that is integrated with WhatsApp. I built this on a platform called Relevance AI, which is quite easy to build agent because they handle all the integrations like WhatsApp, email, and CRM. And I can also add any type of custom tools very easily without worry about deployment and other things. So this WhatsApp agent I built can already have interaction with customers on WhatsApp, which means I can just give it instruction to outreach to someone on WhatsApp, and it will be able to send a message to customers. And users will be able to respond back with any question, and you will be able to answer people's question as well. If they ask question about what's pricing, the agent will be wake up, receive this message, retrieve internal knowledge, and then answer a question back to the customer. What I want to do now is I want to integrate this real-time voice AI that powered by VAPI as well as Groq into this AI agent system. And to do that, it's actually pretty easy. I just need to give this agent a new tool for make a call to customers and also receive the transcription back once the call finish. So I can just quickly create a new agent tool. Let's say call prospect via phone and give description, make a phone call to prospect via phone. Then I need to define the schema for this function, which is input that it will need to take. In this case, will be the agent ID and conversation ID, so that when I make a phone call, I can send those information as metadata. So when the transcription is sent back from VAPI, we will know which agent session need to send those transcription to. And I will have another input for the prospect phone number that we need to call, and also the purpose of a call. So I can get agent to generate the purpose of a call based on the scenario, so it is more dynamic, and even generate a personalized opening line for this conversation. Inside the tool, I will just insert a custom code function to call the VAPI AI API endpoint. So I'll define the URL, the sales name, the phone number ID, which is something you can get from the phone number page, the customer's phone number, and then we're going to create a new assistant on the fly so that we can insert some custom message. So I can give a name of the agent by passing on the sales name. I can pass on the first message that is dynamically generated by agent. I can also put in the voice message that has variables that I want to insert, like customer's name. Then there's a bunch of settings that I found work pretty well. So you can just follow the same setting if you want. But particularly, there are a few things that you will need to turn false if you're using the Groq model, because the mixture model on Groq doesn't support function calling. Then I will define the model, where I will pick up the model from Groq and also pass on the system message here, which is constructed by the prompt that I defined above here, and also passing on the goal of the conversation. Then I will also define the transcriber, the voice model I'm going to use. I will also define the server URL. So this basically means once the call finished, they will do an API request to the server URL and then send all the information like the transcript, so that the agent can receive the full context, understand what has been discussed, then take any actions from there. And in the end, I will also define the metadata that I want to send to the server URL as well, which is my Relevance AI agent ID and conversation ID. And in the end, we will put together the header with the API endpoint and do a post request. So that's pretty much it. The last thing we need to do is we will need to set up server URL. So for server URL, I will use Pipedream as the middleware to receive all those information and decide what the next action should be done. In our case, will be take out only the transcript and then send this new message to our agent. And if you've never heard about Pipedream, you can think about like Zapier, but designed specifically for developers. So in Pipedream, I can set up a webhook trigger, which it will give you this URL that you can use to send out information. This will be the server URL that you will put here to send information. And you can use this to test. So you will get a full JSON like this. It includes a bunch of different information about this call. Part of that will be the summary of the call and call transcript, which is the thing that we want to send back to the agent session. And the way this works is that after VAPI makes a call, it will continuously send updates to this server URL. So there are multiple different types, but only the type which is end of call report will include the full transcript. So what we want to do is, after set up this webhook, we will first add a condition. It will look at the value from the response, which is trigger.event.body.message.type. And if that type is exactly end of call report, then we will want to execute a custom code step here. And if the type is exactly end of call report, Then we want to execute this code, which in our case will be calling the agent. So it will look something like this: import the authentication token I have in Relevance AI, get the agent ID, conversation ID, transcript from WebP AI. Then define the URL, header, and send this message to agent, which is, I just called the prospect, below is the transcript. That's pretty much it. All I need to do now, just edit this agent and give this new tool that we just created called call prospect via phone. So now I can just go back to WhatsApp and then send a message to agent. So now you can see this message has sent back to my agent, and it start calling this function called. You can see it called a function called call prospect via phone. And if I switch to my phone, I actually do get a phone call from the AI agent. So I can click accept to receive it.
Hi, Jason. I'm reaching out from Crazy Fitness regarding your interest in our gym memberships. I'm here to provide you with all the information you need and answer any questions you might have.
Thanks for calling.
No problem. So what specific fitness goals are you looking to achieve?
I just want to lose some weight. I haven't done exercise at all for the past 3 or 6 months since COVID.
I totally get that. Our personalized training and nutrition programs can help you reach your weight loss goals. Let's discuss the membership options that are best for you.
Okay, sounds good. I think I'm pretty happy to just go ahead and get the membership started this Saturday, if possible.
Great to hear that. To complete the process, I just need your credit card number to secure your membership.
Okay, so my credit card number is 1234123442314231.
Thanks, Jason. You're all set. See you on Saturday.
All right, thanks. Bye-bye. Once I finish the phone call, it will actually send the transcript back to the agent session. So you can see that it has message, just call the prospect, below is the transcript. And based on this transcript, then the agent will be able to decide next step. And in this specific case, it decided to send a WhatsApp message confirmation back to me. It says, your membership has been purchased successfully, and we are excited to see you on board this Saturday. So this is a quick demo of what you can build with the power of real-time AI to build this kind of multi-channel AI sales very easily. But again, this is just one demonstration. There's so many possibilities you can do with this type of real-time conversation AI. So I'm very keen to see what kind of use case you guys start building with the power of Groq. It really opened up a huge amount of use case. So please comment below for any interesting AI projects or use case that you want to start building with the power of Groq. I will continue posting interesting AI project I do on this channel. So please subscribe if you want to keep update. Thank you, and I see you next time.